So today is February 8th, and I'm working on the rudder today. So this is the drawing of the rudder assembly, how it goes together. So there's a rudder cassette up here at the top, which goes into the slot in the boat, and that's attached to the, there's basically a rudder shaft that comes up through that, attached to the tiller, and this is the rudder down here. And then obviously when you need to, you can, basically pull the rudder out if you're coming into a beach, that kind of thing, which makes it nice. And the way he's got it designed here, there's a tube, a stainless steel tube, and a couple of 1/4-inch pins drilled through that, and then a bunch of pieces of wood glued together that fit around the shaft and are integral with those pins, so that the pins basically embedded inside this wood framework keep the rudder turning when you turn the shaft. That's how he's got it set up. And so what I'm doing is a little bit different. So as you probably saw in a previous video, I've got a solid shaft, 3/4-inch solid shaft, and then pieces of stainless steel welded to that shaft with pins through those pieces to create a like a cage framework. And then into that I've inserted some plywood blocks, epoxied those all in, covered them with fiberglass on both sides. So now I've got a really hard, very serious thing that's very well attached to the shaft, so there's no way it's going anywhere. So then what I needed to do is I needed to mock up the rudder cassette. So I'll just show you quickly on the boat. This is where the rudder cassette goes in, and what I did was I angled this the slot much more farther aft than in the original drawing. So the rudder would be angled more aft and less vertical. His is almost basically vertical, and it's got a slight aft tilt to it. This is much more angled aft. And the reason for that is that I'm going to be using this boat primarily in Maine, and there's lots of lobster traps, and it's a pain in the neck when you get a rudder or something caught on a lobster pot wharf. So the centerboard is deeper than the rudder, so hopefully if I run over something, it just slides off the centerboard. It never even touches the rudder. But if it does get come in contact with the rudder, the angle of the rudder is sloped back so that hopefully it just slides off of that and causes minimal issues. So that's what I did there. But that then necessitates this geometry being different, because you really need the rudder shaft to be vertical in the cassette. So because if that rudder shaft is angled forward, then the tiller, as the tiller rotates, the tiller is going to sweep like this, sort of down towards the middle and up towards the end. And if it's tilted back, then it's going to, sweep up towards in the middle and then down towards the edges, which is just annoying from, people sitting in the cockpit. You really want the tiller going back and forth across the cockpit in a nice even plane. Parallel to the cockpit seats and stuff, and not sweeping some kind of odd arc. So because the rudder's angled farther aft, then that pin has to then come farther aft too, and that's what I've done in this cassette mock-up. So this part here, this part drops really nicely down inside the cassette slot over there, and you can see I've got the rudder shaft in here. So this is actually vertical to the top of the seat, which is basically this piece here sits on top of the seat, and that's vertical to that. And then what I did was I mocked up the rudder. So I wanted a rudder that's a little bit deeper, give me more control, plus it shifts the center of lateral resistance aft, because I've added the mizzen, and though I've adjusted the mainsail a bit to bring that back, I want to ensure that I've got as much lateral resistance aft as I can. So made the rudder a little bit bigger, and it's also really just nice to have better rudder control anyway. So I'm going to basically, then what I did was I made a shape for the rudder. So this is about 16.5 inches deep. The original design's about 12.5 inches deep. So this will be a bit deeper. And I needed to make a piece of wood now to go around this. So what I did was I basically just laid this and the rudder template on top of a piece of plywood that I'm going to use, and now I can just cut this plywood out with jigsaw, and then the plywood will fit over the top of this piece, and then I'll be able to fiberglass this to the plywood sheet, so on both sides obviously, and then I'll be able to add some extra material to the plywood on each side in the middle to thicken it up, and I'll be able to grind it down, round it over in the front, and taper it off in the stern edge, in the aft edge over here, basically giving it a nice hydrofoil shape, and all the time maintaining something that's much stronger. So that's the plan with that. So I'll be cutting this piece out and then putting it over the top of this and glassing this all on, and also working on the rudder cassette. So